Welcome back to another episode from Let's Understand Mathematics. In this video, we're going to be taking a look at simplifying exponential expressions. So basically, we're going to put all of our laws of exponents, our knowledge of the laws of exponents we learned in the last few videos into play here. So without further ado, let's get into the video. So I've wrote all the laws here. So I just want to clarify one thing about expressions. So expression has numbers, an unknown variable, and an operation, right? But for an equation, you would have an equal sign. You would have numbers of an unknown variable, operation, and you would have an equal sign. So you are able to solve for the unknown, isolate and solve for the unknown. But in this case, unless you're given the variable of a, you can only solve it if you're given the variable of a. So that's basically the difference. Here you can solve for the unknown, you have an equal sign. Here you can only evaluate or simplify. You could simplify as what we're going to show you above. And then once you simplify, if you're given the values for A, B, and C, for like this example, then you could solve it and figure out here, and then you could solve it. But without, this one has no equal sign. Equation has an equal sign. That's the only difference. Okay, so that being said, let's get into the lecture. So in this case, we have an expression. We have numbers, we have coefficients, we have an unknown variable. Coefficient is a number before the variable, and we have unknown. We're dividing in this case. So when we're dividing exponents, a to the power of 6 and a to the power of 2. So if you notice here, we're dividing exponents with the same base. So what do we do when we're dividing exponents with the same base? We are this law. So we are subtracting the exponents. So we have a bases of a, b, and c. All of them have exponents. We're dividing all a, b, and c. We're also dividing these coefficients here. So we got to do them step by step. So let's do it step by step. So 4 divided by 20, what does that give you? So 4 over 20, you could actually simplify it. You could divide it, you would get a decimal 0.2, and but we could actually simplify it and leave it as a fraction since the question asks us to simplify. So using our knowledge of the greatest common factor and simplifying fractions from the videos earlier, we know the greatest common factor between 4 and 20 is 4. So 4 divided by 4, 1. 20 divided by 4, 5. So we have 1 over 5. Okay, 1 over 5. We got these two numbers. We've dealt with these two numbers now. Okay, so I'm just gonna multiply each of them one by one to show you how I do it step by step. Because if you realize that 4 times a to the power of 6, b to the power of 3, c to the power of 4. If you multiply all of that, you'll get what's in your numerator, and same with the denominator. If you multiply 20 times a squared times b squared times c to the power of 5, you would get what you have in your denominator. So I'm just going to multiply it step by step just to show you individually how you would tackle this kind of question. So we solved our coefficients. Now let's get to the variables. So we're dividing exponents with the same base, a to the power of 6 divided by a to the power of 2. That would give us, I'll show it to you here, a 6 minus 2, a to the power of 4. So a to the power of 6 divided by a to the power of 2 equals a to the power of 4. So a to the power of 4. We're done with a. So now what do we do with b? We're doing the same thing. B to the power of 3 divided by b to the power of b squared. So 3 minus 2. b to the power of 1, we'll just leave it as b. Now c to the power of 4 divided by c to the power of 5. So c to the power of negative 1. Because 4 minus 5 is negative 1, okay? Now, when you're looking at exponential expressions, you won't always use one law to simplify it. You may, so an easy one like this one, a to the power of 6, if you get something like this, you'd use one law. is just dividing exponents by the same base. But in some questions, while you're simplifying, while you go one step at a time, you notice that once you use one rule of law and simplify it, you'll have to use another law. You may have to use the zero exponent rule or the negative exponent rule, and etc. So sometimes you will have to use multiple rules. So you have to be quick. You have to be quick to identify it based on your knowledge of this. So make sure you guys know this well, because you'll have to identify it as you go on. Because some people just use one step, even though there's like three rules in that question, in order to simplify it further. So just keep that in mind. So if we notice here, okay, we have 1 over 1 to 1 over 5, 1/5 times a to the power of 4. Yes, that's correct. Times b to the power of 1 times c to the power of -1. If you notice here, c to the power of -1, what do we have here now? We have another rule or law of exponent, which is the negative exponent rule. So what do we do in a negative exponent? We are just taking the reciprocal. So 1 over c to the power of x. So c to the power of x, in this case, the x represents the exponent, which is 1. So times 1 over c to the power of 1. I can leave it as c. So now all I have to do is just solve. So I have a denominator now. I have 5 in the denominator and c in the denominator, because this goes in the denominator and then the rest goes into the numerator, because 5 and c are in the denominator part of this question. So 1 times a to the power of 4 times b to the power of 1 times 1. So 1 times 1 gives you 1. I could put 1, or I could just leave it like that, because you automatically assume there's a 1 there. And then a to the power of 4 and b. So that is how we solve exponential expressions. Notice how I used dividing exponents with the same base. So I used dividing. First I analyzed it. I realized that we were dividing here, so we have the same base. We're dividing exponents with the same base. So dividing exponents with same base. And then once we saw with the second step, I realized we have a negative exponent. We could have left it, but that wouldn't be, you would lose marks for that. So you have to make sure you use all your rules of or your laws of exponents to solve these expressions. So I realized there's a negative exponent. That's step 2, and then I tackled it here, and then I just organized everything and just solved it. So I multiplied they realized there was a denominator, so we have some stuff left in the denominator. So we have 5, and then we have c. So 5 times c, 5c here in the bottom, and then top we have 1 times 1. So that's 1. A to the power of 4 times b. So a4 times b would give you a to the power of 4b. b over 5. So that is how you simplify exponential expressions. But if you're given the a value, b value, and c value after you simplify it, then all you have to do is just plug it in and you'll get an answer. So that's the difference between expressions and equations once again. So that being said, that is how we simplify exponential expressions. We'll look at some more complicated examples in the next part. So thank you very much.